Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna.
And I'm Avery. It's Monday, February 9th, 2026, and we've got a fascinating lineup for you today.
We certainly do, and there's a definite theme emerging in our first three stories. It seems everyone's headed to the moon. We're talking SpaceX, European Aerospace, and NASA's Artemis program all making lunar headlines.
That's right. Beyond the moon focus, we'll also explore new discoveries about auroras, solve a 40-year mystery about Uranus, and catch up with SpaceX's return to flight after a brief grounding.
Let's dive right in with what might be the biggest surprise in space news this week.
In a major strategic pivot, Elon Musk announced Sunday that SpaceX is putting its long-standing Mars colonization plans on the back burner to prioritize establishing a settlement on the moon.
This is quite the reversal, Avery. For years, Musk has been the biggest cheerleader for Mars, making it almost synonymous with SpaceX's identity. What prompted this shift?
It comes down to practicality and timelines. According to Musk's post on X, SpaceX believes they can achieve a self-growing city on the moon in less than 10 years, whereas Mars would take 20-plus years. The key difference is launch windows.
Right. The orbital mechanics are completely different. You can only travel to Mars when the planets align every 26 months, but launches to the moon can happen every 10 days. That's a massive advantage for rapid iteration and development.
Exactly. Musk said easier access means they can iterate much faster to complete a moon city than a Mars city. And this isn't just about SpaceX's preferences. It also aligns with President Trump's space policy directive from late last year, which focused on getting Americans to the moon by 2028 under the Artemis program.
SpaceX is a major contractor for Artemis, so this alignment makes perfect business sense. But I have to ask, what about all those Mars promises? Musk has blown through several previous estimates before.
He has indeed. Back in 2016, he said passengers could take off for Mars as soon as 2024. And in 2011, he told the Wall Street Journal it would be 10 to 20 years. But he's not completely abandoning Mars. Musk says SpaceX will still strive to build a Mars city and will begin doing so in about 5 to 7 years.
So it's more of a reprioritization than a complete abandonment. The moon becomes the proving ground, the place where they perfect the technologies and techniques needed for off-world settlement, and then those lessons get applied to Mars.
That's the plan. It's actually a more measured approach than what we've heard from Musk in the past. Let reality and results guide the timeline rather than ambitious predictions.
While SpaceX refocuses on the moon, Europe is also making moves in that direction. German space technology company OHB announced it has established a new subsidiary called the European Moonport Company.
This is interesting timing. The company was actually founded back in May 2025, but they only made it public on February 4th. The CEO, Marco Fuchs, said they're supporting Europe's ambition to establish a permanent presence on the moon independently.
Independently is the key word there. What exactly will this company do?
In the near term, it's primarily consolidating OHB's existing moon-related activities. They're already involved as a subcontractor on several European lunar missions, including providing subsystems for European Space Agency's Argonaut lunar lander, which is expected to launch in 2031.
And they're also working on the Esprit module for NASA's Lunar Gateway space station, right?
Correct. These contributions are part of Europe's barter arrangements with NASA to secure flight opportunities for European astronauts to the Gateway. But OHB has bigger visions. They unveiled a concept for a central launch and landing base on the lunar surface, developed with Munich Airport International.
An airport on the moon. Though I imagine it's more concept than concrete plan at this stage.
You're right. The article describes it as a high-level concept, basically a model used for the press event. But here's where it gets politically interesting. OHB's press release claimed Germany took a lead role in lunar exploration at ESA's November 2025 Ministerial Council meeting.
I sense some skepticism in that phrasing.
Well, the evidence doesn't quite support that claim. While Germany contributed the largest single share to exploration at 885 million euros, That contribution was made at the program level, rather than being specifically earmarked for the moon. Based on element-level commitments, Italy actually committed the largest share to ESA's moon exploration element at 284 million euros.
So perhaps more aspiration than actual leadership at this point. Still, it shows Europe recognizes the moon's strategic importance and doesn't want to be left behind.
Absolutely. This is the second such specialized company OHB has founded recently. They established the European Spaceport Company in November 2025. It shows they're serious about building infrastructure for the new space economy.
Speaking of getting to the moon, let's check in on NASA's Artemis II mission. There have been some developments since the wet dress rehearsal that concluded on February 3rd.
Yes, and it's a bit of good news, bad news situation. Technicians discovered higher than allowable hydrogen gas concentrations during the test and have been working to address the issue.
What exactly was the problem?
The elevated gas levels were found in the tail service mast umbilical on the mobile launcher. Once the rocket's tanks were drained of cryogenic propellant, technicians immediately accessed the area and replaced 2 seals around the fueling lines.
These tail service masts are pretty critical, right? They're about 3 stories tall and provide the cryogenic propellant lines and electrical connections to the core stage.
Exactly. They tilt back before launch and include quick disconnect mechanisms that instantaneously separate at liftoff. Getting these seals right is crucial for a safe launch. Engineers are analyzing the removed seals and developing plans to address all issues ahead of the next wet dress rehearsal.
When do they expect to complete the repairs?
Reconnecting the interfaces is expected to be complete today, February 9th. They're also planning testing at NASA's Stenson Space Center in Mississippi to evaluate additional dynamics of the plates, and they're reviewing options to test the repair work prior to the next wet dress rehearsal.
I noticed they're also making some operational changes for the next rehearsal.
Right, they're streamlining to focus on fueling activities. The Orion crew module hatch will be closed prior to the test, and the closeout crew won't be deployed to the launch pad. The crew access arm won't be retracted since they successfully demonstrated the ground launch sequencer can retract it during the countdown.
And they've added extra hold time?
Yes, 30 minutes of extra time during each of 2 planned holds in the countdown, giving them more troubleshooting capacity. The total countdown increases by 1 hour, but it won't affect the crew's timeline on launch day.
What about the astronauts? Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen must be eager to get going.
They've emerged from quarantine and continuing training activities, reviewing flight day details and ensuring their familiarity with Orion systems is second nature. NASA still eyes March as a next potential launch opportunity, but they won't set a targeted date until after a successful wet dress rehearsal and data review.
Patience and precision. That's what it takes to safely send humans beyond low Earth orbit for the first time in over 50 years.
From the moon to phenomena much closer to home, an international research team has finally answered a question that's puzzled scientists for decades. What powers the electrical fields that accelerate particles to create auroras?
The northern and southern lights are one of nature's most spectacular displays, but we're still learning about the fundamental physics behind them. What did they discover?
Researchers from the University of Hong Kong and UCLA found that plasma waves traveling along Earth's magnetic field lines, called Alphen waves, act as a natural accelerator. These waves supply the energy that drives charged particles into the atmosphere, producing auroras.
How did they figure this out?
They analyzed data from multiple Earth-orbiting satellites, including NASA's Van Allen probes and the Themis mission. The data showed how these Alphen waves maintain the electric fields that would otherwise dissipate by continuously transferring energy to the acceleration region.
So it's a sustained process, not just a one-time jolt of energy.
Exactly. Professor Zonghua Yao from HKU, who leads the team, said this discovery not only provides a definitive answer to the physics of Earth's aurora, but also offers a universal model applicable to other planets in our solar system and beyond.
That's the really exciting part. His team has long focused on auroral processes of giant planets like Jupiter and Saturn. By applying that planetary knowledge to the high-resolution data available near Earth, they've bridged the gap between Earth science and planetary exploration.
It's a perfect example of how interdisciplinary expertise advances our understanding.
The UCLA team brought deep knowledge of Earth's auroral physics, while the HKU team contributed their expertise in planetary magnetospheres.
And now we can apply these insights to understanding auroras on Jupiter, Saturn, and potentially exoplanets with magnetic fields. It's fascinating how solving one mystery opens doors to understanding phenomena across the universe.
Speaking of planetary mysteries, let's head to the outer solar system and revisit an anomaly from 1986. Remember when Voyager 2 flew past Uranus and detected unexpectedly high radiation levels?
That flyby has puzzled scientists for nearly 40 years. The radiation readings were much higher than anticipated based on our understanding of planetary radiation systems. What's the explanation?
New research published in Geophysical Research Letters suggests that Uranus was experiencing a rare space weather event during Voyager 2's visit, a solar wind disturbance called a co-rotating interaction region, or CIR.
These are the same kind of events that affect Earth's radiation belts, right?
Exactly. CIRs occur when fast solar wind streams overtake slower ones, creating a region of increased energy. Dr. Robert Allen from the Southwest Research Institute led the study and said they took a comparative approach, looking at Voyager 2 data alongside Earth observations made in the decades since.
So basically, Voyager 2 just happened to visit Uranus during a cosmic storm.
That's the working theory. On Earth, these events can dramatically accelerate electrons in our radiation belts. Dr. Sarah Vines, a co-author, pointed out that in 2019, Earth experienced one of these events that caused an immense amount of radiation belt electron acceleration. If a similar mechanism interacted with the Uranian system, it would explain the unexpected energy Voyager 2 detected.
It's remarkable that we're still extracting new insights from data collected almost 40 years ago. What are the implications for future missions?
Dr. Allen says this is just one more reason to send a mission targeting Uranus. The findings have important implications for similar systems like Neptune's magnetosphere. Understanding how solar wind and radiation belts interact across different planetary systems helps us refine our models of space weather throughout the solar system.
And it reminds us that single flyby observations, while invaluable, can catch planets in unusual states. We need return missions to build a complete picture.
Absolutely. Uranus remains one of the least understood planets in our solar system, and this discovery makes the case for a dedicated orbiter mission even stronger.
Finally, let's bring things back to current operations. SpaceX successfully resumed Falcon 9 flights on Saturday, just 5 days after standing down due to an upper stage anomaly.
The return to flight came with a Starlink mission from Vandenberg Space Force Base in California. The Falcon 9 lifted off at 12:58 p.m. local time, carrying 25 Starlink satellites.
And everything went smoothly this time?
Perfectly. The satellites were deployed as planned about an hour after liftoff. The first stage booster, making its 13th flight, successfully landed on the drone ship Of Course I Still Love You in the Pacific Ocean. Most importantly, the upper stage performed as expected.
That's a relief after the February 2nd incident. What exactly happened during that flight?
After successfully deploying its Starlink payload, the upper stage experienced what SpaceX called an off-normal condition. A gas bubble formed in the transfer tube ahead of the planned deorbit burn, preventing the stage from reigniting. The vehicle then performed as designed to passivate the stage, which re-entered over the southern Indian Ocean about 10.5 hours later.
So it wasn't a catastrophic failure, but it wasn't nominal either. How quickly did SpaceX turn this around?
Impressively fast. They submitted a report to the FAA including the likely cause and corrective actions. The FAA cleared them to resume launches earlier this week, and here we are, back to flying. This was SpaceX's 15th launch of 2026.
With over 9,600 active Starlink satellites now in orbit, these launches have become almost routine, but each one still requires meticulous attention to safety and reliability.
Absolutely. And speaking of Starlink, this particular mission added 25 more satellites to the constellation, continuing to expand global broadband coverage.
What a lineup today! From SpaceX's strategic pivot to the moon to Europe's lunar ambitions, NASA's Artemis preparations, and fascinating planetary science discoveries.
The moon is definitely having a moment. It's exciting to see this renewed focus on our nearest neighbor, not just for scientific exploration, but for permanent human settlement.
And solving mysteries about auroras and Uranus reminds us that there's still so much to learn, both in our cosmic backyard and in data we collected decades ago.
That's it for today's episode of Astronomy Daily. Thanks for joining us.
For the latest space and astronomy news, visit our website at astronomydaily.io. You can also find us on social media at AstroDailyPod. Don't forget to subscribe wherever you get your podcasts so you never miss an episode.
Clear skies, everyone.
And keep looking up.
Astronomy.